Truly leveraging and benefiting from streaming data is hard. The data stack is costly, difficult to use, and still has limitations. Materialize breaks down those barriers with a true cloud-native streaming database, not simply a database that connects to streaming systems. With a Postgres-compatible interface, you can now work with real-time data using ANSI SQL, including the ability to perform multi-way complex joins, which support stream-to-stream, stream-to-table, table-to-table, and more, all in standard SQL. Go to dataengineeringpodcast.com/materialize today and sign up for early access to get started. If you like what you see and want to help make it better, they're hiring. Data and analytics leaders, 2023 is your year to sharpen your leadership skills, refine your strategies, and lead with purpose. Join your peers at Gartner Data and Analytics Summit from March 20th to 22nd in Orlando, Florida, for 3 days of expert guidance, peer networking, and collaboration. Listeners can save $375 off of standard rates with code GartnerDA. Go to dataengineeringpodcast.com/GartnerDA to find out more. Your host is Tobias Macey, and today I'm interviewing Ori Rafael about the SQLake feature for the Upsolver platform that automatically generates pipelines from your queries. So, Ori, can you start by introducing yourself?
Yes, my name is Ori Rafael. I'm the CEO and one of the co-founders of Upsolver, and I come from a data engineering background.
And for folks who haven't listened to your past appearances on the show, can you give a bit of a reminder about how you first got started in data?
Yeah, I started in the Oracle age, owning about 50 Oracle databases, supporting application team and BI teams. So those were my first steps. Did that for a few years and kind of started to go more into cloud in the last 6-7 years.
And in terms of the SQLake product, we've done past episodes about your work on Upsolver and some of the aspects of unifying batch and streaming workflows. And this is the latest iteration in terms of the user experience and kind of the functionality of what you're building. So I'm wondering if you can give a bit of an overview about what it is that you've built there and some of the story behind how you came to the conclusion that this was the right feature set to build and some of the, I guess, user challenges that you're trying to address in introducing this capability.
And I think that SQL, we don't call it a feature. SQLake is a full product. You can call it the V2 of Upsolver, basically destined to eventually replace the original Upsolver and kind of having the, as you call them, conclusions from the previous iteration. And I hope the name helps with that, is the combination of having SQL to writing big data pipelines, but doing it on top of a cloud data lake environment. Let's say the framing of the problem you're trying to solve. You're trying to build a big data pipeline in the cloud. You're storing your data in the lake, and eventually you're going to deliver it either to engines that query the lake, or you're going to deliver it to data warehouses. That's the problem they're trying to solve. And the North Star for the company has always been ease of use. We come from a database background. We like SQL. We can do a lot with SQL. And the velocity of developing on open sources like Spark wasn't what we were used to. It was something that we had to take a lot of the work on ourselves because we couldn't really give Spark to citizen data teams. And it just took a long time to do. So we tried to basically bring the SQL, you can even say sometimes Oracle-like experience to the world of big data pipelines. Now that's Upsolver in general. Now look, why SQLake? What's different? So the original Upsolver product used the user interface to build pipelines. We still use SQL for your transformations, but the pipelines themselves is something you build with a drag and drop type of environment. What we figured out is we wanted to create a system that's very well defined, has a very clear API. UI, you can take to many different directions, but when you have an API, you can just implement that API, you can document it, you can test it, you can bring something that's much more familiar for data engineers, for data teams, without us explaining it. So we felt like our entire system needs to be SQL-based, just like you would with a database, but in this case, this is a sort of database that you're using for moving data, not necessarily for querying data. The other reason to use SQL is the ICD. I think the market did a pretty big shift in the last few years, Informatica type of experience to I want to own my pipeline code, I want to test it, I want to be able to manage it as I manage all my other code. And in this case, we're giving you SQL code. So instead of you learning our internal APIs to create pipelines, that's kind of the API behind the UI that you see, everything is SQL based. You do that, so managing deployments, managing tests, managing all of that becomes much easier once you work with a SQL system. How does CI/CD work in Upsolver? Well, how does it work in a database? You write your SQL code, you manage it. It's the same. The original name for SQLake in Upsolver was database experience. How do we provide database experience for the people trying to build big data pipeline?
As far as the pipeline management aspect, you mentioned that in the initial implementation of Upsolver, you went for a UI-driven paradigm of being able to construct the pipelines and manage the data flows. A lot of other people are going to be familiar with tools such as Airflow and some of the other tools of that generation. Lately, there have been kind of a new generation of data orchestration systems that are trying to be more data aware in terms of things like Dagster, Prefects, Flight. And I'm wondering if you can talk through some of the anti-patterns that you've seen teams start to adopt in the space of the kind of UI-driven or very task-oriented workflows that they have come to be accustomed to, and some of the ways that you're trying to address some of those anti-patterns and kind of prevent people from being able to fall into those bad practices with what you're building in SQLake.
Yeah, the two words data aware are the key words. So pipeline is the combination of two things. It's the transformations that you write and it's the orchestration of actually to run those transformations. Transformation is a necessary step. Like you need to define your use case. You need to define what you want to do with raw data. How is it becoming analytics ready? But orchestration is kind of a necessary step that we do, but it's not adding any value. Basically, let's turn a one-time query into something that runs continuously. So orchestration is, I think, the big anti-pattern. And this is not something that only Upsolver is saying. If you look at the big data platform like Databricks and stuff, like they are talking about declarative pipelines. How do I take a transformation and turn them into a pipeline without additional engineering? Now, if you look at the Airflow approach, the Airflow approach is by design not data aware because it's not the system running the pipeline. You need to write code to define when can I actually run a step, the dependencies between the steps, always creating those dependencies, harder to do. And there are a lot of dependencies. Processing state, I have additional tables I want to merge with, I want to do aggregation. Like there are a billion cases for stateful processing, and it's hard to do on something like an Airflow just because you have to define all of the dependencies. They're not inferred out of your transformation. So let's say, in my opinion, it will be hard to make Airflow a data-aware tool because it doesn't hold the data, it doesn't do the processing. Another system is doing the processing. This is why we are seeing declarative pipelines coming from Databricks and Snowflake, not exactly seeing it from Airflow because they are not the engine processing. So we kind of figured out that was in an early stage in Upsolver, that we want to have the processing engine and orchestration together so we can make the orchestration completely automatic. Let's say the number one enemy for getting ease of use was orchestration. So if defining the dependencies is one anti-pattern, the second anti-pattern is trying to force a batch system on a streaming workload. So I remember writing ETLs in my Oracle days. I could write a query, it would run once a day. Sometimes it ran for an hour or 2 or 4, but nobody cares because the data comes every 24 hours. You can scan a lot of historical data. You can just do a lot, and you don't really need to think about your pipeline as a continuous process. Once you start going more real time, and even hourly batches is more real time. I'm not even talking about the companies doing once a minute. Once you do that, you need to really be thinking incrementally. And your pipeline, if I'm looking at the online documentation, usually people would say that you shouldn't force streaming into something like an Airflow. And now you have to think in two different ways. I have one system for batch, I have one system for streaming. Our goal was to unify them and kind of not make the user think too much, is it streaming or batch? Let me know what's the data freshness that you need. Give me that contract. Let me figure out how to run your pipeline, but don't try to force that batch process where you're not thinking about very small incremental step with a lot of dependencies. And the point that it breaks is streaming. So companies trying to just take Airflow and build their streaming workloads with that, we often see that fail.
In terms of the unification of the management of the transformation and the orchestration into the SQL dialect, I'm curious, what are some of the trade-offs that you considered around the kind of benefits of putting everything into that same language versus being able to more natively represent some of the kind of orchestration and sequencing constructs that might be necessary for more complex use cases?
So the model we chose to work with, so in Upsolver, you have tables and jobs. Those are the two main entities. Okay, so and the jobs move data between tables. That's clear. Now, how does a job work? So I could write in Upsolver create job. I have properties of the job like the refresh interval, when do I want to start, but it's basically properties. You don't need to know a lot of syntax. You just need to get familiar with the properties. And after that, there is an SQL clause. That SQL clause needs to be as close as possible to an ANSI SQL clause. And in most cases, just 100% ANSI. So you as a user come, you write your query, you said, this is my transformation. Now you put a create job on top of it, you define those properties, and that's basically the contract of the table you're going to create. Now you want to create more tables on top of that, you can do that. From each table, you can create another table. That's the model you work in Upsolver. So I'm going to tell the user, you write the query, learn the part about writing create job and some properties, and now you have a pipeline.
As far as the kind of orchestration primitives that you're building in, what was the kind of level of detail or granularity that you wanted to expose to the user, and maybe some of the ways that you thought about who the kind of target consumers are of the SQLake platform and how that informed the kind of level of detail and control that you wanted to expose versus just making it a smooth end user experience so that they don't have to worry about some of the inner workings of what their tasks are actually doing?
I think it's more the latter. I'll explain what we do give to the users, but I think the approach is it's just too much to put on the user. One of the things that we did is we created a system table that shows you, like you can query with SQL and see all the orchestration tasks and the status that one ran and what didn't run, and we're creating views on top of it so it will be easy to query, but it's still very complex. Like I'm not expecting the average user, because if I'm going to start the most vanilla pipeline ever, it's still going to create a table. It needs to update metadata. Let's say if I'm using something like a glue catalog or a Hive metastore, it needs to do compaction of small files. It needs to apply retention policies. So you have like three different angles in which you are going to update the table for a vanilla use case. I'm not even talking about the case where you're updating the table for multiple jobs or writing replays or fixing data on specific time interval. So basically our approach was to try to basically abstract orchestration completely. What we do ask users to do is to define their interval, like how often they actually want to get the data. There is a bunch of stuff they can do to play with sliding time windows. That's more for the streaming use cases. It's usually for the streaming use cases. And one thing we introduced that wasn't in Upsolver Classic is the concept of sync jobs. So the concept of sync jobs says that all the tables that are being, let's say I have a chain of tables and all of them are connected with sync jobs, it means that all of these tables are going to maintain a timeline of the data. And if minute 1 didn't get into table 3, then the jobs for table 4 and 5 wouldn't continue their processing. So the entire pipeline from start to finish is going to be managed on a single timeline. That's very important for streaming, but not only, because it gives you a lot of control over your data. Let's say I have some data quality problems, and I identify that it's in between 12 o'clock and 1 o'clock at night on a specific day. I can just rerun that piece, and then the entire change is going to propagate along the pipeline, because the entire pipeline is synced into one timeline. So the concept of sync jobs is one way you can work. The other concepts say, I don't care about timeline, just write into the table. Whenever there is available data, write into a table. So for example, I have some kind of reference data. I'm using an address book. So I don't care about the time I updated the address book. I just want the most recent addresses, and I don't care about sync jobs. But if, for example, I have a click stream and I want to take two different events and join them together, the time means something here. If the two events, for example, the sessions are correlated, I can't run the two jobs in completely different times. And if I'm going to do a replay, then maybe I'm just going to run one stream and not run the other stream. So those two are not going to be synced. I'm going to get bad results. So we in the past didn't give the user the option to choose between two modes, synced or not synced. And today they can do that. So that gives them more flexibility.
In terms of the implementation of SQLake, I'm wondering if you can talk through some of the kind of design and technical aspects of it and some of the ways that you were able to build on top of your existing investment in the previous generation of the Upsolver platform and cases where you had to either kind of throw pieces away or rebuild or re-engineer it.
Basically, SQLake is built on the Upsolver processing engine, which is running in production since 2018. So that's the processing engine that we are very certain of. We didn't write it from scratch because the processing engine works well and we tested it at scale. What we did do, I think the approach of the original Upsolver Classic was let's create an entire data architecture as materialized views. So I have my raw data and I have materialized views on top of that. And what we found out kind of when you face reality is there are a lot of changes people are doing to their tables. First of all, that materialized view, quotes materialized view, changes a lot. Adding columns, I'm removing columns, I'm doing a lot of schema changes. I think that I've seen cases where I've seen over 100 edits for one pipeline from a single user. The second is that people are really good at screwing up their data, and it needs to get fixed a lot. There is no real meaning to the concept of doing random changes to materialized views because they are the result of a query. But sometimes you want to change data more ad hoc. So we decided that we are still going to keep the concept of materialized views, but we are going to separate jobs from tables. In the past, each job, if one job equals one table. Today, you have tables, you have job, you can have multiple jobs running into one table. There is more flexibility on the entities, and that's solving all of those more, let's say, edge use cases that we saw over the last few years. So kind of separating the engine to addressing tables and jobs as two different entities was something that was a redesign. I think the second was to take a look of SQL and saying, well, we want a full support of SQL. What don't we support and what don't we support as SQL? For example, you could edit materialized views in Upsolver Classic. We don't have that concept anymore because editing materialized views was very confusing for our users. What version of data am I currently looking at? That kind of was a question that came up a lot. And if I'm running this materialized view, what data is it going to override? Let's look at even a small to medium data lake. You can take a data lake of 100 terabytes and decide to just recompute your materialized view. It's not practical. Everything is an evolution. You never recompute everything from scratch. So that was a redesign on that part.
In your redesign and reimplementation of Upsolver into SQLake and orienting around this declarative approach to managing the transformations and the pipelines, what does the workflow look like and some of the pieces that you're trying to optimize for in the customer experience as you are rolling this out and getting people onboarded to it?
I think the intention of SQLake, like the user experience we are showing to users, is there are two personas in Upsolver. There's a data engineer persona and there is a data consumer persona. What would a data engineer do? They will set up the account, they will create the connection, they will set up the initial ingestion, they will put the raw data in the lake. They will provide the initial access. Now, if I'm going to look further and I'm going to look at the data consumer has a contract with us. They write queries, we deliver pipelines. That's what we are trying to deliver in the user experience. So they're doing create job that's basically wrapping some kind of transformation SQL that they're writing. When we started Upsolver, we kind of looked at everything as one single motion, and that's really not the case. Each one of the users has a different life in the system. The data engineers want to get started fast. They want to make sure that you're going to ingest in a secure way. They're going to think about cost. But the data consumers, they just want to work in an easy way. So we wanted to just write a query. What you need to do in Upsolver is you need to write a query, and everything was kind of derived from there.
Because of the fact that the entire user experience is oriented around SQL workflows. I'm curious how you've thought about some of the additional tooling around that for being able to manage things like versioning, composability, code reuse. And I'm thinking in particular around things like dbt, being able to use some of those paradigms to apply to SQLake, both for the transformations, which people are already using dbt for, but also managing kind of reuse and templating around some of the pipeline logic.
So at the day of the release, we are already, there's a nice demo of it, but basically if you work in a Git environment, you can manage the Upsolver pipelines using Git actions. And feedback on that was very good so far because most people use Git, and Git actions was a familiar process, at least to the customers we have worked on it so far. We think that dbt is a great tool for managing deployments and kind of managing my data pipeline ecosystem. And we are building a connector where you basically will be able to write the Upsolver SQL from dbt. dbt will not be doing the orchestration. That's basically one difference. Well, dbt core doesn't do the orchestration, but if you are in dbt on the cloud, you do get the orchestration. So we are not behind the approach of let's do my orchestration on dbt because everything we said about Airflow still applies here. But I definitely would want to see like Upsolver customer manage their pipelines and deployments and different environments using dbt, and you can use Python scripting language to basically wrap the SQL.
Are you struggling with broken pipelines, stale dashboards, missing data? If this resonates with you, you're not alone. Data engineers struggling with unreliable data need more than Monte Carlo, the leading end-to-end data observability platform. Trusted by the teams at Fox, JetBlue, and PagerDuty, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo monitors and alerts for data issues across your data warehouses, data lakes, dbt models, Airflow jobs, and business intelligence tools, reducing time to detection and resolution from weeks to just minutes. Monte Carlo also gives you a holistic picture of data health with automatic end-to-end lineage from ingestion to the BI layer directly out of the box. Start trusting your data with Monte Carlo today. Go to dataengineeringpodcast.com/Monte Carlo to learn more. In terms of some of the challenges that people experience around composability and code reuse in SQL, I'm curious how that influenced your choices around some of the extensions to the dialect that you were designing and ways that you were trying to kind of reduce the potential for conflicts or code repetition and being able to optimize for the kind of software engineering practices that a lot of the data community is trying to adopt.
A few things on the dialect. First of all, every time you write an SQL clause, so I said create job, that SQL clause, then we try to keep it ANSI. Like if you're going to try to go non-ANSI, there's an Upsolver architect that's going to jump at you from some from some point and telling you that you're basically breaking the contract of the system. But we did extend ANSI, especially if you look at the streaming. There are some functions for doing streaming, and there are enrichment functions like IP to geo, unpacking user agent, those type of things. So that's extension, but it's just additional functions. One area where Upsolver kind of diverted a little bit from ANSI, and there is a good reason for that, is nested data. We feel like SQL is not the first choice for software developers for nested data, because SQL is trying to force you to flatten the data back and then work on it, and you're losing the relationship between parents, siblings, and sons, which is important in an object like JSON. So we invested a lot of time in allowing people to work with SQL, but on top of a nested context. For example, I have nested JSON data and it has arrays. I could actually add an enrichment in the context of the array item. And I could do operations between arrays. Let's say we take two arrays in Upsolver, do array A plus array B, and we'll just do an item-wise addition between each item in the array. So sometimes users are not even necessarily understanding that what they're doing is a very complex operation. They just work on the nested object. They don't need to start doing all of those flattening. And I feel like that's a place SQL is going to go to. If you look at Amazon's open source PartyQL, they are already trying to do something like that. In order to do that, we allow you to create like parameters, like local parameters in a query using a let syntax. You can add that almost after every clause in the query. And we allow you to work in a nested context without flattening. Those were two major things that are still not part of ANSI, that was invented quite some time ago, but we are a data pipeline company. Raw data in many cases is nested, and we want to provide an easy experience for unpacking it. So that felt to us like a good enough reason to break the ANSI contract for that use case.
The other complex aspect of what you're building is the question of orchestration, which is something that companies have dedicated their entire focus on. And so having it be a component of a broader platform is definitely very ambitious. And I'm curious, what are some of the complexities and edge cases that you've had to address in building your orchestration system, and maybe some of the prior art that you looked to for inspiration on how to implement it in your SQLake platform?
I think that the first part of it is that we are not building the same orchestration system as they do. Like, we have architected Upsolver differently. So Upsolver, we set the words data aware. It stores all the data it ingests on a data lake on a timeline. So you have the starting point is consistently ordered data on a data lake. Now, what are the tasks that Upsolver is running? So each task is going to be defined by some kind of time period. A minute of data is going to be a task. So I don't need to ask the users to define the tasks for me. What's a task? I'm going to infer that myself using the data that was ordered. So the architecture is a little different, because we are not trying to do trigger-based or time-based orchestration. We are trying to do only data-aware orchestration for data pipeline. So we are solving a smaller problem and trying to do that in a very good way. Now, what are the side use cases? I think the hardest part was what I described before, the synced versus unsynced. That was pretty hard to do, to make sure that you have a data pipeline. It has 6 jobs, and all of those jobs are going to be synced without asking the users to define those dependencies. That was pretty hard to do. And I think that the other part was trying to make the system seamless for stream and batch use cases. So when we started, Upsolver was really just optimized for streaming system. Today, it's also optimized for slower batch workloads, which means that you need to take a different sharding strategy. Sharding is something that's hard for the users to really get to do well. How many shards do I need for every pipeline? In what case? It's something that you really need to understand the internals, and getting everything to work with auto sharding was hard to do, and definitely very related to the orchestration.
In terms of the initial feedback and some of the early feedback that you've gotten from people who are already using SQLake, what are some of the sharp edges or escape hatches that they've asked for in terms of being able to maybe delve deeper into control over the way that the data is being transformed, or some of the operational characteristics of being able to work with that data, and ways that you've been able to wrap that back into your product development?
Escape hatches is always important. Having UDFs, for example, is always a good escape hatch. You know, you're not going to get stuck on syntax. I think one escape hatch was just a redesign I described earlier on SQLake, was separating jobs and tables into 2 different entities. So you can have multiple jobs writing into the same table. That creates a lot of flexibility for use cases we were struggling with for the 4 years that preceded SQLake. The other thing that's not in the system yet and is going to be soon is having direct insert, update, and delete. So you can fix your data manually in cases you don't want to write it as a pipeline. And also to support the GDPR use case. So you could be able to delete users. They have the users the ability to be forgotten, even if your data is in a data lake. That's something that makes a little more sense to do with in DML, insert, update, delete. So that's one escape hatch that we are still adding. But those were the main ones.
Another aspect of what you were talking about in terms of timeliness, as I was reading through some of the documentation around what you're building at SQLake, it was talking about being able to automatically manage the partitioning and chunking of the underlying data so that you can parallelize across it. And I'm curious, some of the challenges that you're experiencing in being able to manage the timeliness of a given pipeline as the volume or complexity of the underlying data scales.
So I think the first thing it was to build the Upsolver processing engine as a headless creature. So we don't have a single coordinator node or manager node or something like that. That's a single point of failure. That is done with data-aware architecture I described, because every period of data is a task, and every task is going to be idempotent. So it's going to write the exact same bytes every time you're going to run it, regardless of the time you're going to run it. So I can actually look at the file system, and the file system is going to help me understand what's the next task that I want to run. So let's say I'm going to move from a 4-instance cluster to an 8-instance cluster. I'm going to get 2x on performance. It makes it much more predictable to understand, am I actually going to need to support my use case? Now, on top of that, 3 scaling policies, sometimes even do some custom ones, but 3 general scaling policies. One is optimizing for lower cost, and another is optimizing for consistent lower latency. And the difference between them is basically how aggressive you want to be with scaling up and then scaling down. So that's the second mechanism.
Another interesting challenge that a lot of people in the data ecosystem are trying to address is how to think about pricing and what are the reasonable units to use for computing usage. And I'm wondering if you can talk through your journey of that experience and some of the ways that your experiences with the initial implementation of Upsolver have informed your current approach to how to bring SQLake to market and make it accessible to a wider variety of companies.
So there are 2 parts to that. The first part is the model, what is going to be the units that we are going to use. And the second model is the entry level. Do I need to pay 5 figures, 4 figures, 3 figures? Like, how much do I need to pay when I actually get started? Now, when Upsolver started to sell its product in 2018, we chose a compute-based model. So basically based on number of CPUs. Now, the problem with that is that CPUs has an indirect relationship with the value that you're going to get. I'll give you an example. I have a pipeline that's running on 16 instances, and now I need some more RAM. So I need to double up, and I need to go to bigger instances, and now I'm paying double for the same pipeline, for the same volume of data without create additional business value. That creates friction with users. It creates predictability problems for buyers. So I'm not a fan of going to our buyer and telling them, hey, I know you've bought for X amount, but now you're going to probably end the year at 4X. Maybe you should go talk to your CFO. That's not a good conversation you want to send them having. And it's very hard for them to predict how much it's actually going to cost, and it prohibits usage. We talked about that quite a lot. I think it was a 6 months project of talking to users, understanding what to do. And we decided that the Upsolver unit of economics is going to be volume of terabyte ingested. Emphasis on ingested. What does this mean? You, Tobias, are going to ingest data into Upsolver. You're going to pay $99 per terabyte that you ingest. After you ingested the data, you can run as many pipelines as you want. We are not going to charge a software fee from you. The Upsolver is going to run in your account. You're still going to pay for the instances, but the payment for the instances is so low because it's spot instances. It could be like 2% of what you would pay for the same capacity for a data warehouse, for example. So the cost of the instances is almost negligible. And on the other hand, you understand exactly that if you're processing 100 terabyte a year, and next year you're going to process 150, then you understand how much you're going to pay for the Upsolver software. And it also ties much strongly and much better to your business value. So if I have a game and my game 100 terabytes per year, and now it's going to yield 150, probably it's because I have more users. And I have more users, I'm willing to pay more for the data. So it tied better to my business objective. It was more predictable, and the users just loved it. Like, we started migrating from existing customers, talked to a new customer. We closed some deals. We're stuck on compute-based model. We love the data ingested model. It's much, much simpler to explain also. I, Ori, as the founder, am no longer a deal desk for all the salespeople. They can just give very simple pricing to their customer, and we can lead with pricing. So instead of asking you to do a POC, and after 2 months, tell you how much is it actually going to cost because we actually need to try it, we can tell you how much it's going to cost before the POC. You know if it makes sense to change an existing system and even to invest resources in this project. So this is the reason why we made the change, and we're very bullish about that change. Now, the entry point for Upsolver in the past was roughly $20,000. So we wouldn't start unless you would pay an annual fee of $20,000. We would only look at kind of doing a sales-led type of motion. And today you can go sign up to Upsolver, start paying $99 per terabyte. If you have a terabyte a year, you're going to pay $99 for the year. So you're not going to pay a lot for data volume, especially if you work on your own. If you work with us, we do charge for the ongoing support services. But if you are independent, and you can be independent on an SQL only system, the cost is very low for you to get started.
In terms of the applications of SQLake, now that you have people using it and applying it to their problems, what are some of the most interesting or innovative or unexpected ways that you've seen it used, or workflows that you've seen people build around it?
As a data engineer, I tend to drift to the technological examples that are really cool, and those are usually scale ones. So seeing a single workload with 3 million events per second and over 100 petabytes a year, that was pretty cool to do. It was so much data for that customer that sometimes we just ran out of EC2 instances in the region when we needed to do a replay or things like. You start facing problems that you didn't even think about when you start planning. So I think that very big data lakes was one. The second was, I would say, streaming. So for example, a company doing oil rigs, and they were able to really see the data in a 15-minute, 20-minute, 30-minute delay, and now getting that in under 1 minute latency. Now that sensor data is bringing a lot more value. It's meaningful for the organization at very different levels. That was very cool to see. And maybe the last, like one of the problems that got me into Upsolver was a problem where to build machine learning models over advertising data, and we needed to get to very fine-grained user information. So the fact that people are building a pipeline that's enriching the ad opportunities that I'm looking at with information about 1 billion users, and you have granular information on 1 billion users, and you can do that process 100,000 times per second based on what we create, that was very cool. Yeah, I kind of drift for high-scale use cases, and I think that the business use cases, the real-time ones, are the ones that are the coolest.
In your own experience of building SQLake and overseeing its development and rollout, what are some of the most interesting or unexpected or challenging lessons you've learned in the process?
Maybe I'm still digesting, but I feel like switching to an SQL system from a UI-based system creates, like you're basically selling people a database. We're selling something that's very, very similar to a database. We have to be very creative in how we teach them to use that database, so it wouldn't be like a knife you can draw but never use it. How do we provide a lot of examples? As a result of the early user feedback of how do I actually find an example to what we're doing, SQLake has the concept of templates built very strongly into the product. Every time we see a nice use case, we just add the template to it. And there is a power of community here. As more customers join into SQLake, we can create more templates. They can create more templates. And now you have an example for every pipeline that you want to do. So you can tell the story of an entire data infrastructure, but on a single document of SQL commands. And that tells a very powerful story. And until we started talking to customers, we didn't understand that the system is the template. And we kind of just gave them this SQL empty worksheet and thinking that they will take it from there. And we covered a lot of ground as a result of that. We added snippets, we added templates, like as many examples we can have. Like there's a GitHub repository, like there's a bunch of examples as a result of that early feedback.
For people who are interested in being able to simplify the operational aspects of managing their data, what are the cases where SQLake is the wrong choice?
I feel the why now for SQLake is going more real time. So I kind of put the line in the sand in 1 hour. So if you're not interested in delivering data on an hourly basis, maybe like old style orchestration is good for you. Like it's not that you don't have good batch alternative, not that Airflow is bad at it, something like that. Like that problem is a solved problem. And if you don't have the need to go modern, then don't. Maybe then Upsolver is not the tool for you. I think maybe the second option is if you need a connector tool. So if you want to bring data from a bunch of SaaS applications, that's not the Upsolver use case, at least not today, more of a five-train type of use case. Upsolver is focused on streaming data coming from Kafka or Kinesis, data, files, and object storage, and database replication. Database replication, something that we added about a year and a half, 2 years ago. So those are the three main main types of data, bringing data from Salesforce and HubSpot and kind of creating the marketing data warehouse based on multiple connectors. That's not an Upsolver.
As you continue to build and iterate on SQLake, what are some of the things you have planned for the near to medium term, or any particular problem areas or projects that you're excited to dig into?
There are a few. So I think that the first one that's going to come out is data quality. So basically every table in Upsolver is going to have expectations, and you will be able to basically understand when expectations are being violated and improve your data quality. That's something that we heard a lot about from customers, that they don't want to just define the pipeline, they want to define all of those expectations in order to proactively monitor their data quality. I've heard it enough times that I'm very excited about releasing it. It's already in the works. Other than that, we are going to add support for Iceberg. So now you can write with Upsolver to data warehouses, and you can write to data lakes if you're using a Hive Metastore or a Glue catalog, but we are not creating an Iceberg catalog. That's actually not so hard to do, and we are planning to do this in Q1. This will create a nice opportunity for people using tools like Snowflake, for example. So today, if you're using Snowflake, we first create a copy of your data in the lake, then we push it onto Snowflake, but not your entire data lives in Snowflake. Now that Snowflake support Iceberg tables, we'll be able to create those tables, and you will be able to query your data from Snowflake, whether it's from a lake or from a warehouse. And that's not just true for Snowflake, it's true for any other system that supports Iceberg. So I think that's an important integration that we want to add. One that I mentioned before was direct insert updates and deletes. So you'll be able to fix data manually when you want to not work with a continuous pipeline model. You just want to fix something. It works like a database. It needs to work like a database. Those are the main three that come to mind.
For anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I feel like the gap of data engineering, like this is the number one missing skill gap today. Like it's 4 times worse, I did the numbers, than the gap you have with data scientists. Like you have 1 data engineer for every 2 data scientists, and you have 2 open data engineer positions for every open data scientist position. So like a 4 times gap. It's a big problem. If you ask data engineers, where do you spend most of your time? They're spending on data pipelines. And I feel like this is the biggest rock. This is the biggest thing that data engineers are doing. Then this is the biggest problem to solve, because organizations move in the pace of data engineering. Now, I would very much like to see the world going to a data mesh future, where data teams are independent and data engineers are more enablers, more infrastructure developers than people that are doing ad hoc development for data teams. And by allowing pipelines to be easier, you're increasing the audience that can do data pipelines. So for those 2 reasons, the growth in data mesh and what's currently kind of boggling data engineers today, I think data pipeline is the biggest problem. Like data warehouses, you have a bunch of them. It works very well. So I feel like the problem of moving data is the most time-consuming one.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing on SQLake and having the bravery to completely reimagine the product that you're releasing. So appreciate all of the time and energy that you and your team are putting into making creation and management of these real-time pipelines more tractable. So thank you again for that, and I hope you enjoy the rest of your day.
Thank you, Tobias.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.